my name is Angelica Coriano. I'm a student at Valencia College in the Bachelor's for Electrical Engineering Technology degree. This is my video submission for lab number 6 for CET 2114C, Digital Systems for Professor Evans. This video is going to include parts 1 and 2, with the timestamps being in the description box below. I'm going to begin now with part number 1. So beginning now with part number 1, we were instructed to build this circuit right here, which is a full adder. And this is the circuit I have right here. I'm going to be explaining a little bit more how it's wired right now. So this is the circuit I have right here. There's a lot going on, but I'm going to try to explain it piece by piece. The chips I have here from left to right are the 7483 IC chip, which has XOR gates. 7486 IC chip, which has XOR gates. Then the 7408 chip, which has AND gates, and the 7432 chip, which has OR gates. So XOR gates, AND gates, and OR gates. So I have here 3 long cords connected to switches 0, 1, and 2. Switch 0 is input A, which we see here. Switch 2 is input B, which you see there. And switch 3 is carryover in, which is CN, which is connected there. These 3 have their own rows. So this is input A's row, this is input B's row, and this is input C's row. Not this one, my bad. This one is input C's row. I did rows so that I was able to connect the different gates that I needed to connect from these rows and interconnect them. So the first gates I'm going to show are these 2 exclusive OR gates. In one gate you have B and C in going in, and in the next XOR gate you have A and the output of the first XOR gate. The output of this second XOR gate is S. So I'm going to show that one right now. So my XOR gates are right here. I have right here. It's kind of weird. I made sure to try to connect the same colored wires so that I couldn't make that mistake of. So this green wire right here is connected to the row for input B, which is right here. So input B is this wire right here. And this green wire is connected to that, and is connected into the input, into one of the pins, pin 8, 9, 10 of the exclusive OR gate. So it's one of the inputs of an XOR gate. So we have B going into one of these XOR gates. This next yellow wire, which is in pin number 9, is coming from input C in. So input CN is going into pin number 9, and the output, which is pin 8, is going into another XOR gate. So it's becoming the output of this XOR gate, which is pin 8, is going into pin 1, which is going to be the input of another XOR gate. And then pin 2 is connected to the row with input A. So pin 2, which is the next input for the XOR gate, is connected to pin 2. It's connected to input A. Then pin 3, which is the output, which is S, is connected to LED number 3. LED number 3, my fault, I kept looking at this one. Now, for the carry out, you have 3 AND gates connected into an OR gate. Each AND gate is comparing something different. So you have, not in any specific order, you have C in and A being compared, B and C in being compared, and B and A being compared. So this one, for example, you have B and C in being compared, and then you have B and A being compared, and then you have C in and A being compared. Being ANDed. So and then they go through a 3-input OR gate. In this case, I don't have a 3-input OR gate, so I just did 2 AND gates into one OR gate, and then I took the output of that OR gate and put it through another OR gate with the input of another of the last AND gate. So here we're going to show that one. So I have in the middle is my AND gate chip, which is a 7408 IC chip. So I have 3 AND gates being used here. So the first one I'm going to show is on this side. And all I did for this one, I'm going to let it focus, is I bridged the input A that I was using earlier from here. I should say input A to pin number 1. Pin number 2 is connected to the row of C's, so that input C in. And then that output is connected to pin number, so 12, about pin number 11. 14, 13, 12. Pin 12 of the 7432 chip. So it's the input of one of the first EXOT. It's the input of the first OR gate. Once again, I have input A, input C in through an AND gate, and the output of that AND gate, which is pin 3, is connected to pin number 12 and is the input of an OR gate. The next input of an OR gate I have is right here. It's this brown wire. This brown wire, remember I said I was trying to keep the colors consistent, has input C, that's the row of C's, input B, that's the row of B's. So B and C are going into an AND gate. In this case, it's going to be pins 10 and 9, pin 10 being input B, pin 9 being input C, and pin 8, the output of that AND gate, going into pin 13, which is an input for an OR gate. Now the output of this OR gate, which has the AND gate for B and C and the AND gate for A and C, is being passed through another OR gate. In this case, pin 5 is going to be the output of that first OR gate, which is connected with another AND gate. So the next AND gate we have here is right over here. And we have, yet again, another row of A's here. So I have one row of A here, input A being connected there. And then it's connected here too. So I have another A coming out. This A is being compared to B. So that row where I connected this wire is connected with a green wire. And I'm going to try to flick it right here. So this green wire, these green wires are connected to the B row. And all I did was connect B to the pin number 13. So that's an input of an AND. A is connected to pin 12, which is the input of the other AND. And then pin 11, which is the output, is ran through pin number 4, which is the input of an OR gate. So the AND gate for A and B, the output of the AND gate for A and B is ran to pin 4 of an OR gate with the output of the OR gate that is comparing A and C and C and B. And that output, which is going to be our C out, is connected to LED 0. Oh, I lifted. Anytime I lift, there goes my pencil. Anytime this chip lifts, it will turn that light on. So I'm going to fix that right now. One moment. So I was able to fix that just pushing down the 7432 IC chip, which is my OR gate chip, and it did it again. That's crazy. Making sure it's down. That is one issue I noticed with this one and that I'm having with this lab, is that I tried placing the chip and taking it out and placing it again because it wasn't going all the way down, and it was coming up as showing this one. But anytime I do push it down, it does resolve. So there's that. So I have A, B, C in. I'm told to complete table 6-1. All I did for these inputs was follow the normal inputs, so starting 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, and then 4 zeros and 4 ones. Same thing that we did in the lecture notes for arithmetic digital circuits. So now I'm just going to test these out. My circuit is on. So I have switch 0 being input A, switch 2 being input B, and switch 3 being the CN. So for 0, 0, 0, both lights are 0. So I'm going to put 0 and 0 for my outputs. Sorry about that. 0 and 0. Now, 0, 0, 0, 1. 0, 0, 1. The S is showing up as 1 and a C out is coming out as 0. Now, 0, 1, 0. 0, 1, 0. I'm getting a 1 for my S again and a 0 for the C out. Now, 0, 1, 1. 0, 1, 1. I'm getting a 0 for my sum and a 1 for my C out. Now, 1, 0, 0. So 1, 0, 0. I'm getting a 1 for my sum and a 0 for my C out, my carry. Next one is 1, 0, 1. 1, 1, 0, 1. I'm getting a 0 for my sum and a 1 for my carry. Next one is 1, 1, 0. So 1, 1, and a 0. I'm getting a 0 for my sum and a 1 for my C out. The last one is 1, 1, 1. So I have 1, 1, 1. And I have both sum and C out being 1. And that is my completed table. And in this, what's happening is we are adding A and B. And if there is a carry, it is being added in. And if there is a carry at the end, once these two numbers are added with the carry, the sum is being placed here. And if there's a carry out, it's being placed here. So an example where we have that, we have 0 and 1. So I have 1 plus 1 is 2. So you're going to have a 0 and a 1 will carry. So that's an example of what's going on here. And that is part number 1. Once again, look at my circuit. Now, beginning with part number 2, we were instructed to build this. Well, the instructions are connect the 7483 IC chip, connect inputs A3 through A0, B3 through B3 through B0 to data switches, and then see input directly to power or ground, depending on what we have here. And then we have connecting S3 to S0 to LEDs, and the output or the carry C4 to an LED. And this is the circuit I have right here. Yes, it is on. I'll explain it right now. So I wrote in pencil so that I could easily erase each thing I wrote here. The 4 switches on the right, 0 through 3, are A3, A2, A1, A0. Then 4 through 7 are B3, B2, B1, B0. So I'm going to start looking at my chip. This is a 7483 IC chip. It's kind of a mess here, but I will try my best. So, looking at the first input, which is A3. 3 is that wire right here. It's a white wire. It's connected to, that is not the right one. Pin number 1. So A3 is pin number 1. And that is how you see right there. All right, so a little change here. Since these wires are all kind of on top of my poor IC chip, I'm just going to go through each pin and try to explain which one is which while looking at my switches. So starting with the A inputs. A3 is pin number 1, right there. A2 is pin number 3, which is 2 over. So pin 1 and 3 are A3 and A2. A1 is pin number 8. And A0 is pin number 10, which is right there. So it is white wire blue wire, yellow wire, and 10, which is red wire. So red, yellow, white, blue. Then we have inputs B3, B2, B1, B0. B3 is pin number 4. I'm going to try to look from above, not from the side. Pin 1, 2, 3, 4, which is connected to, you hear, a white wire. So B3 is pin 4. B2, my fault. I actually misspoke. B3 is pin 16. B3 is pin 16. So you can see it starts off with B3. B3 is pin 16. Then this white wire right here, which is pin 4, is B2, which is what follows next. Then we have this red wire, which is B1. B1 is pin number 7, so it's just wire right here. And then we have B0, which is pin number 11. So 9, 10, 11. This wire right here, you can see it goes to the last switch, and that's how B3, B2, B1, and B0 are connected. This wire right here, which is going to pin number 13, is my CIN. I have both ground and positive connected here. I didn't explain on the last circuit, which I should have explained, that I have the 5-volt VCC connected to the positive rail and these generator ground connected to the negative rail. That was my fault. In the last one, all of them had ground and positive in the same pins, all having ground in pin 7 and all having VCC in pin number 14. This one, it's a little bit different. So VCC in is pin 5, which is this brown wire I have here, and ground is pin 12, which is this short white wire I have right there. Short white wire. Both sides are connected to both positive and ground. So this is my CIN that I will just be changing between positive and ground. And then I have here S3, S2, S1, S0. It's a blue, white, black, and then yellow wire. S3 is in pin number 15, which is the blue wire. S2 is in pin number 2, which is the black wire we have right here. S1 is in pin number 6. Let's say 2, 3, 4, 5, 6, which is the white wire. Here's the white wire, pin number 6, which is S1. And then S0 is in pin number 9, which is the yellow wire I have right here in pin number 9. And then I have C out, which is connected to pin number 15, not 14, 15. And I said it wrong again. Pin 14, right here, which is this green wire, which I'm pushing in. This green wire is my carry out, and it is in LED number 3. So LED 7, 6, 5, 4 are S3, S2, S1, S0, and then LED number 3 is a carry out. And that is how my circuit is wired. Now, going through these problems I have. I'm starting off with the first one. I have A3 through A0 as 0, 0, 1, 0. And then 0, 1, 0, 1, 0, 1, 0, 1. And I am getting for my S3 through S0, 1, 0, 0, 0, and no carryover. 0, 0, 0, and no carryover. Next one, I have my carry out connected to ground. So I'm going to connect here to ground. And then I have 1, 1, 0, 1. 1, 1, 0, 1, and 0, 0, 0, 1. 0, 0, 0, 1. And now I have 1, 1, 1, 1, and no carryover. 1, 1, 1, 1, and no carryover. So sorry. No. pause right here just because I need a little bit more space on my camera, but I will continue in just one moment. So, coming back, I was able to make a little bit more space in my storage. And I'm actually going to be redoing this one because both of these, actually not just this one, my bad. Because I said they were both connected, both sides to positive and negative, and I was wrong. I forgot to connect negative. I actually just moved the wire. But the first one wasn't wrong. I did have positive connected, so that one's good. I now have CIN connected to ground, which is 0. And then my inputs are 1101 and 0001. So 1101 and 0001. And instead of what I had before, I now get 1110, no carryover. 1110, no carryover. Awesome. The next one over is 1100. So I'm going to do that one. 1100. And then 1110. 1110. 110. Yep. 1110. And it is connected to ground again. Indeed. I'm getting a number of 1010 with a carryover of 1. Alrighty. Next one, we have CN being connected to positive. So I'm just going to move that wire to positive. And the inputs are 0110. So I'm going to try that now. 0110. If you can see that, it's out of focus. 0110. And then 1001. So 1001. 1. So 0110. 1001. That's what I have, and a carry of 1. And the number I'm getting is 0000 with a carryover of 1. So 0000, a carryover of 1. Now, it said choose your input combination to record the output. Honestly, I was kind of curious about doing them all high, so I'm ripping them high, except for the carryover. I didn't want to do the carryover high. I wanted to do the carryover low. So, I have 1111, 1111, and a carry in, of 0. So they're all high, 1111, 1111, and my carry in is on the ground. And I get 1110 with a carry of 1. I get 1110 with a carry of 1. Kind of looks like the second option, but just with the actual carryover. Now, the next one I chose was just the simplest. Adding 1 with a carryover of 1. So I'm going to move this one to positive, which is my carry in. And I have A being 0. So all 4 switches go to 0. 0, 0, 0, 0. And then B just being 0, 0, 0, 1. 0, 0, 0, 1. And I am getting 0, 0, 1, 0, no carryover. Which makes sense. 0, 0, 1, 0 with no carryover because, if you add 1 here, it's going to be 1 plus 1, which is 2. So you put a 0, then you bring in the 1 over, and you have 0, 0, 1, 0. Makes sense. The last one I have was kind of a flip of one that is up to the first one. So the first one, I kept the input high, but I flipped which one is going which. So in this case, I have 0101 for, oh wait, that makes no sense. I'm an idiot. Let me redo this. I didn't mean to call myself that. It just came innately because this is an adder. So before I had these two numbers flipped, which makes no sense because it's the same exact thing. Addition is commutative. It goes forward and backwards. So I changed it so we can see 1111. So my input A3 through A0 is 1110, 1110, and then B is 0001 again. Oh, I should have thought about that too. And I have a carryover. That means I've already done this. No, I didn't. Oh, I know what I did wrong. I meant to put my carryover as 0. So I'm gonna move my carryover to 0. And yet again, I have 1, 1, 1, 0, and then 0, 0, 0, 1. And I get, yay, addition matters. 1, 1, 1, 1 with no carryover. So that is my table and my experiments for labs number 2. This is once again part number 2, where we use the adder IC, which is 7483. I used all the big jumper wires because this time I was actually using the breadboard that comes with the lab kit, and this is what I got.